This tiny valve can automatically control water, gas, steam, or even fire suppression systems without anyone touching it. But how does it actually know when to open or close? Let's find out.
Solenoid valves are used to convert electrical energy into mechanical energy. Solenoid valves have quite a distinctive look about them. As you would expect, they have the valve body, but on the top they have a block which will have some cables coming out once the valve is installed. This top part is the solenoid and the bottom part is the valve, therefore making a solenoid valve. Why do we use solenoid valves? Well, these valves allow engineers to autonomously and remotely control the flow of fluid within a system. This fluid can be a liquid or a gas, for example water, air, natural gas, oil, steam, refrigerant, etc. The list goes on and on. The solenoid coil on the top is used to operate the valve by passing an electrical current through it to create an electromagnetic field and operate the valve. This means if it is controller, it can be operated autonomously and remotely by a computer without the need for engineers to physically run around opening and closing valves. This allows systems to run much more efficiently and safely. With the direct operated valve, we have the solenoid on top, which is basically a coil of wire. As you may have seen in our electrical videos, when you pass an electrical current through a coil, we generate an electromagnetic field. This magnetic field is what we'll use to control the valve. We have two types of valve, the normally open and the normally closed type. Let's look at the normally closed type first. So inside the valve we have the armature. The solenoid is placed over this and completely surrounds the armature so that it's at the center of the magnetic field. Inside the cylinder of the armature is the plunger and spring. The spring pushes the plunger down in a normally closed type valve. Because the plunger is pushed by the spring, it will sit in a down position to close the valve indefinitely. But if the coil receives an electrical current, then it will generate an electromagnetic field, and this magnetic field passes through the plunger and will cause it to move upwards against the spring, therefore opening the valve. At the center of the coil, the magnetic field lines are the most compact and therefore the strongest. This is why we place the plunger in the center. Once the electrical current is stopped, then the magnetic field disappears and the spring will force the plunger